Hello and welcome to the fourth lecture in exploratory data analysis part 1. Actually, in previous lecture, by mistake, I said that the chapter is over and all that, but I forgot that actually some discussion here is required. Okay, so we had said that these things are covered in univariate analysis. One, descriptive statistic, so that we have already seen, df.describe, that will give the summary statistic for all numerical columns, and df.describe include equals in quotes object that will give the summary statistic for all categorical column. Measures of central tendency, they are also coming in the this df.describe only. All mean, median, more will not come, but more can be obtained for categorical data in a slightly different manner, and that we have seen how to do that by our code. Dispersion. Now dispersion is indirectly shown by the box plot, whether the box plot is thick or thin. Depending upon that, you can see that variance and standard deviation and range and interquartile range. For example, say this, I will show you some box plot. These are the plots which we have plotted and we have saved in employee details. Okay, so they are them only. I have kept all open so that we can quickly do the discussion. So among the box plots, yes, this kind of plot. Now this is one box plot, and similarly I will open this another in, say, separate window is not possible. Okay, show in anyway. So you can see that this one was thicker. So that means that this variance of the data is over a larger region compared to this one. It is thin. So the variance and standard deviation are less. This one is more or less like previous one only. This is the previous one and this is new one. Just the median has shifted towards a higher level compared to the previous one, but thickness wise or variance wise both are one and the same. Then this shows the highest amount of variance. As such, this is a completely meaningless plot because it is the box plot of employee ID. Now it is not meaningful because somebody could have given employee IDs from 1 to 3, 4, etc. So I am simply closing this and I am even deleting that. So this is how the reporting process slowly will start. Okay, so box plot of employee ID, this I don't need it, so I will delete it. Okay, so yes, then maybe this box. Okay, now histograms. So for histograms, I am saying that this is the histogram. Age, performance ranking. So age, this is the histogram of age and it is showing a very nice normal distribution, because normally also if you take a large number of samples, then human beings are such that their age, height, etc. are almost normally distributed. So it shows a normal distribution. Employee ID histogram, now that is meaningless once again because that is this. Okay, so I am simply deleting that. There is no need, closing and deleting. Fine. Now then there is one other salary histogram. Salary is also distributed this way, but here it appears that it is not perfectly symmetrical, but it is on slightly lengthened or skewed towards the left side. Okay, so then this is what is the situation. And similarly, this is the department histogram. So here this salary cannot be, salary is also nearly normal. So you can keep it and then do the discussion that there is nobody in your organization who has the salary between 20 to 30,000, and there are large number of people who have salary between around 45,000 to 55,000. Okay, so this is the count. Frequency in histogram means count. So how many are at say 55,000 or 52,000, then 7. How many are at 50,000, then horizontally you go and 4. How many are at 49,000 or 48,000, then again 7. So maximum number of employees are in this range. So if the firm decides to do some cost cutting, then rather than announcing layoffs, which will make some people permanently jobless, there is another option also that some salary cut can be announced, or these people may not accept salary cut and they will leave the firm, but new persons can be hired in same position with same qualification at slightly lower salary, and that salary can be redistributed over this region. Okay, so that is one thing. Then you can say that there is one large 3 employees are there who have the highest salary, and because whenever you prepare the report for your client, because earlier I showed you the whole data science life cycle, then you can see here dashboard is to be prepared. Client will just give data CSV file and he will just look at the dashboard. All these intermediate things are not his botheration. So you can see that's why from EDA we are doing data visualization and we are saving that so that we can use those whatever are useful. Then we can use them in our dashboard or our reports. Okay. Then this missing value heat map is not much useful again, because we right from the beginning, before doing univariate analysis only, we use clean data in which there were no missing values, there were no duplicate array rows, and there were no single valued columns, and there were no outliers. Okay, so I can delete it. And similarly here, missing value heat maps, the whole folder I can delete. Okay, so initially this is how they work, that they try to find maximum number of visualizations, but not all visualizations are reported to the dashboard. Only some which provide some insights, they are reported to the higher people in the organization. Then this is pie chart of employee qualification. Now you can see that pie chart is very nicely explaining here. But pie chart has above pie chart, some people have reservations that they should not be used, etc. But I would still prefer that use pie chart, but use it when categories are less. So here there were only 4 categories: master degree, bachelor, high school, and PhD. And you can see that you can see the distribution of your employees qualification in one glance compared to seeing them in numbers in a table or something. This is much better. So this I will definitely want to keep and report to the client, so that client gets idea that okay, some work is being done on my so this is about qualification. Then next pie chart. Now this pie chart is not useful because it is what? Employee's date of birth. And we saw earlier that there are only 1 or 2 employees who have common date of birth. Otherwise, all 50 employees have their unique date of birth. Whenever there are so many categories, pie chart completely becomes meaningless. So I am closing this and I am deleting this pie chart. Okay. Same will be pie chart about the date of joining. Now that also is meaningless because so many categories are there. So close it and delete it. Okay. Now pie chart of employee versus department. So how many employees are working in various departments? Now this is also very indicator pie chart that which department is contributing maximum to the salary burden of the whole firm, and in return whether sufficient returns are being generated by that department or not. Also, as technology changes, maybe you need to strengthen IT department, but you want to keep your total headcount of firm 50 constant. So where there is a scope of reducing employees, then maybe finance same work which was handled by a large number of people, that can be handled by slightly 2 or 3 less number of people, like that. Okay, so you can report this. So this is worth reporting. So therefore, I am keeping it. Fine. Then employees marital status. Now, as such, this is an interesting piece of information, but beyond a certain limit, this has no value for prediction of salaries, because you don't give different salary to employees based on whether you are divorced or whether you are married or what. Of course, there are certain theories which say that married employees are usually more stable, married and widowed also, compared to single employee or divorced, young and divorced employee, because they have more freedom and they can switch the job. So you can predict a few things from this. So if you want to keep, you can keep it. Okay, fine. Now let us see what other chart is. Bar chart. Now this is more or less like pie chart only. It gives head count department wise. So if you want to keep bar chart, then don't give pie chart, or vice versa, because ultimately both are giving same information. So pie chart, bar chart of employee department. Okay, so this is that. I'm at present keeping it, but in the reporting only bar or pie one will go. Then bar chart of employee marital status. Okay, so bar chart of employee marital status. Now these married, widowed, single, divorced. Okay, so there you can see that it is just like that pie chart, but again not much significant. And if you are already going to include that pie chart, then I think delete that. So try to reduce the number of plots as much as possible at every stage. This is how the actual practice of data science is done, because now still bivariate analysis is pending. So you can understand the number of plot goes on increasing. Now this is the bar chart for qualification. Again, pie chart was sufficient because it was giving number and it was also giving percentage. So maybe I think I can delete these also. Okay, and then bar chart for employees in various departments. I think I can delete that also because the pie chart was sufficient. Now about the bar chart of 2 dates, they are. I am already, even before opening, I am knowing that they are going to be too clumsy. This is the bar chart for date of joining, and this is the bar chart for date of birth. No insight is there, and not much not any value from the insight point of view or knowledge point of view. So maybe just delete them. In any case, if you need, the date of birth and date of joining are already there in your data set which you have saved, so delete that. Now this density plot, they are important because they show the distribution, but even in that you can see that we have plotted histogram such that it already includes the density plot. For example, this is the histogram of age. Now let me show you the density plot of age. So then it will be like almost capturing the same thing. So you can keep any one and ignore other one. Mostly histogram plus density plot, they are usually preferred. But here I am keeping at present. Employee ID density plot is completely useless, so I am deleting that. Employee ID has no importance, so delete it. Employee performance ranking density plot, well, okay, that will be required because that roughly shows the standard bell curve theory, that actually there are only some center of around 23% employees which are performing at the peak or near peak level. Rest of them, their performance keeps on decreasing on either side. Okay, so you can keep it. And salary also is nice distribution, Gaussian distribution. So I am now closing this. So we have done now box plot we have done. So discussion. So that's it. Okay. So this much is about that various points which we learn from univariate analysis. Now if I see that where is that chapter, univariate analysis? Yes, this. So what each parameter gives. Then one is this histogram, box plot, density plot we have already seen. One is the violin plot. So this violin plot I am keeping pending at present because we have not yet done it, but we are going to do it very soon in the next chapter. Okay, so violin plot is pending. Remember that I will cover it in next chapter. Then there is another somewhere strip plot must be mentioned. So strip plot is yeah, here, or swarm plot. So that also I am keeping pending because we are going to include in the next chapter. Okay, then count plot, that is well, it is the same as bar chart or pie chart will do. So it will give count of employee with different qualifications. Because count plot per qualification or count plot per department, that will give count of employees in various departments. Outliers detection can be handled. In our case, we used the clean data set in which outliers were already kept within the limit of plus or minus 1.5 times interquartile range from first and third, that is Q1 and Q3. But outliers can be removed. Okay, now missing data analysis also, that is not applicable in this case, but in other cases that is applicable. Shape and modality. Now unimodal, bimodal and multimodal. So sometimes it happens that the density plots are not just one. In fact, this is slightly bimodal already. This is one peak, then it troughs, then it again increases slightly. Though this is very mild, but sometimes it increases even this much and then comes down. So then you will say that my plot is bimodal. Okay, so similarly multimodal, more than two modes are there, peaks are there, then multimodal. Then patterns and anomalies, if there is some seasonality in your data. Now seasonality means this is the age data, but instead of that there is a sales data, suppose, then it may vary like sine curve somewhat this way. So initially sales are very less, maybe in the month of March or something, because March ending is there and people are saving for tax purpose and all that, so they will be spending less. But then a festival comes and the sale increases. Then again the sale goes down. Then next festival comes and the sale increases. So Diwali sale, then maybe next is 26 January sale, and next maybe Holi sale, and so on for Amazon or Flipkart, that kind of e-commerce retailer. So it is a seasonal variation. So that we can understand from this univariate analysis. So seasonality, clustering we can understand. Now clustering we have not shown here in any plot because the data is such, but sometimes it is possible that if given observations are say 200, then out of them 100 have some matching characteristics, and therefore when you plot their location on x and y axis, then they all will come very close to each other and far away from other observations. So that we say that one cluster has formed. Then we can plot it in one color, say red. Then 50 observations have that kind of characteristic out of 200. Maybe 80 observations have some other characteristics. So they will appear far away on the XY plot from that red cluster, and we will prefer to show them by a different color, blue color. And similarly, rest 70 may have some totally different characteristic than the first two clusters. So then we will show them by say orange color. So there will be distinct groups of points on the graph paper at three different locations. So such clusters can be seen. Uniformity can be seen, whether the data is uniformly spread across categories or not. That means, for example, educational categories are there. Okay, and if I see that bar plots, by plots I have all deleted, but maybe pie charts. Then in pie charts, qualification wise, so it shows that there is not much uniformity. If I see these three categories, PhD, high school and bachelor, their proportion is more or less equal, but master category almost dominates and 34.6%. But suppose these five categories are there, 1, 2, 3 and 4, sorry, 4 categories, then all 4 categories have 20, 20, 25, 25%, making total 100%. Then in that case, you will say that 4 qualifications are uniformly distributed in my organization. So we can get some such idea. We can also get idea about the scale of measurement. Now that I already told you that our data set was such that the minimum and maximum value for salary are 19,000 and 73,000, but for age, minimum and maximum value are 21 and 49, and for performance ranking, minimum and maximum value are just 2 and 11. So in other words, the scales are pretty different. That much is clear. And if scales are different, then you will have to do the feature scaling or normalization to bring all at same scale. Okay, then this numerical summary is itself statistical summary. Histogram is we have already done. Outliers not applicable. Skewed data I have already told you that if there is a skew detected. Now in our case the distribution was such that there is some mild skews somewhere, but not much actually. If you see this density plot, some light skew on this side appears, but not much, or maybe this slightly skewed, but not much. So these are not worth applying log transformation. Okay, so that idea we get that whether to apply log transformation or not. For example, income data will always show all over world. Income data always shows some kind of positive skew because there will always be some people uh, in a capitalist regime, or nowadays almost whole world has become capitalist. So then there will always be some people who have extremely high income, like Elon Musk maybe, or Bill Gates maybe, or Larry Page, or in India, Mukesh Ambani or Gautam Adani, like that. So if you plot income data of entire population of a country, then there will always be people who have extremely high income, and therefore the whole plot will skew towards higher side. Okay, so you can do log transformation to reduce the skew. Then, so ultimately, what is the outcome of univariate analysis? So it tells you what kind of feature engineering will be required, either log transformation, scaling, etc. It detects errors like impossible values. For example, in each column has some value, say 250. Now, then its histogram will clearly show that all other values will be in one region, but one observation will go far away. And box plot will also show incorrect data type. That also will occur because then you will not be able to do the statistical summary or plot the graph itself. For example, you are using df.describe, but there are describe works only for numeric column. Now, if there is one numeric column in which all 99 observations are numeric, but by mistake one observation the data entry operator has entered one string, then immediately df.describe will throw an error and red colored error message will come. So you can easily detect that this is a numeric column, then why this string data has come. Then it lays the foundation for more advanced analysis, because now in next stage we are going to do that only, bivariate or multivariate analysis. So what feature transformation is required? Feature engineering, impossible values, feature you can say feature cleaning, then bivariate and univariate analysis. Next stage, you can see that after EDS, the next stage will be feature engineering only, right? Of course, we have done only one part of EDS so far, that is univariate analysis. In next lecture, that next chapter, we want to do bivariate analysis. Okay, thank you, and see you in chapter 10.